this video, I would like to find the distance from the point -635 to the plane x minus 2y minus 4z equals to 8. Okay, first I'm gonna find the formula for a general case, and then we're gonna apply the point and the plane into the formula and find the distance. Let's see what we have. We have a plane like this, and we have a point, let me call it P0, with the coordinates x1, y1, and then z1. This is given, and also the plane is given. And let me write equation of the plane in a general case would be ax, a is just the number, plus by, b is the number, cz equals to d. Basically a, b, c, and d are just numbers, and the variables are just x, y, and z. Okay, I'm looking for what? I'm looking for finding the distance from the point P0 to the plane. Let's see what we have. On the plane, we have something that is very useful, and it's called the normal vector. We call it n, the normal vector. And based on the equation of the plane, the coordinates of the normal vector would be the coefficients of the variable. If the plane is in the general format, it would be a, b, and then c. These are the coordinates of my normal vector. Okay, to find the distance, what I'm gonna do is to basically pick a general point here on the plane. Let me call it P with the coordinates x, y, and z. Okay, this point P is one of the points in the plane. And then I look at the vector P0. Okay, so I have a point on the plane and the given point outside of the plane. And then I'm looking for the distance here. As you see, this distance would be kind of like the distance from the point P to somewhere in here. And what is this? Let's look at the projection of the vector P0 over n, which is this vector. If you remember, this vector is the projection of the vector P0 over the vector n. And if I want to give you a recall of the projection, if we are given a vector a and I have another vector, let me call it b, then the projection would be a vector up to this point. This is the right angle, and this vector is called projection. So projection of A on the vector B is equal to what? Basically, this projection is a scalar times B, because as you see, the projection vector is in the direction of B. So this is a scalar times B. But what is this scalar in here? The scalar in here is A dot B. As you know, the dot product of two vectors is a number. So a number on top, and I have the length of B squared in the denominator. So this is a number, this is a number. So I have a number times B. This is called the projection vector, this yellow vector in here. Okay, now go back to the plane. If I find the length of this projection vector, as you see, the length of this would be exactly the distance from the point P0 to the plane. Okay, so I'm gonna write this distance from P0 with the coordinates x0, y0, and z0 to the plane ax plus by plus cz equals to d is the length of the projection vector of P0. P is an arbitrary point on the plane. P0 is the given point on the normal vector. Great. Now, let's find the formula for the length or the magnitude of the projection vector in here. So, projection of P0 over n. It's what? Go back to definition of the projection vector. It is a number times n, right? Because it is in the direction of the normal vector. And what is that number? Would be the dot product from P0 dot n, and it's over the length of the normal vector square. Okay, so that is the projection vector, and I was looking at its length. Okay, so it would be what? It would be the absolute value, because this is the number. The length of a number doesn't have any meaning, so it would be the absolute value of P0 dot n over absolute value of n squared, but the length of the vector n is just a number. When you square it, we get a positive number, so the absolute value of a positive number is the number itself. That's why we leave it as that. And then the length of n. Okay, the only vector that we can take the length of is n. Everything else is just a number. Now I'm gonna kind of simplify this expression in here. So I just get the length of n. So it would be the absolute value of P0 dot n over the length of n. So let me write everything. What is P0? It's a vector, and the vector would be the coordinates of the end of the vector minus the coordinates of the beginning of the vector. So it would be x0 minus x, y0 minus y, and z0 minus z. This is P0. That n, the normal vector, has these coordinates a, b, c, and it's over the length of n. The length of the vector n would be square root of a squared plus b squared plus c squared. Okay, so let me simplify that a little. I cannot simplify the denominator even more. B squared plus c squared. How about the top? I have a dot product. It would be a x0 minus x plus b y0 minus y plus c z0 minus z. And the absolute value of that, it's important. So I get the same denominator. How about in here? I have, let me distribute a, b, and c into the parentheses. I get ax0 minus ax plus by0 minus by plus cz0 minus cz. Okay, now look at here. Ax plus by plus cz is equal to d. Ax, by, and then cz, all of them has a negative sign, so if I raise all of them, I get a negative d. So I have the absolute value of ax naught plus by naught plus cz naught minus d over the the length of the normal vector, which would be the square root. Okay, so instead of that, I can write this notation. Let me erase them. So the formula here, I'm gonna bring this one in here. The formula that I'm gonna use is ax naught plus by naught plus cz naught minus d over square root of ax squared plus b squared plus c squared. This is the distance. As you know, a, b, c, and d are given. These are the equation of the plane. X naught, y naught, and z naught is the point, and over the length of the normal vector. So this is the formula for the distance. Now let's apply it to the given point. So the distance from the point P naught, which is -6, 3, and 5, to the plane like this. Actually, let me have the better plane, like this one, which is x minus 2y minus 4z equals to 8, is this. A, B, C are 1, -2, and -4. And basically, as you see in here, just plug in the point for x, y, and z in the formula of the plane. So I get -6 minus 2 times 3 minus 4 times 5. And then this is d. I'm going to bring it on the other side. -8 over square root of the normal vector, the length of the normal vector, which would be 1 squared plus -2 squared plus -4 squared. So if I simplify that, I get what? I get -6 minus 6 minus 20 minus 8. So this is -40. So I have -40 in here. Don't forget the absolute value because distance is always positive. This is a positive number on the denominator, so on the numerator we should have a positive number. So don't forget the absolute value. And then here I get 1 plus 4, which is 5, plus 16, 21. So the length is 40 over square root of 21. That's the length.